Okay, so we're going to look at different straight lines, and we're going to look at families of straight lines. So straight lines that look the same, perhaps. So let's type in here y equals 2x minus 2. And that is the straight line y equals 2x minus 2, and it's graphed very, very quickly. Let's look at another one. Y equals 2x plus 1. What we can see is that that's y equals 2x plus 1. And we can keep going. We can y equals 2x plus 3. Now the question is, what do we notice about those three lines that's the same? And what do we notice that is different? So there's a couple of things that are the same and a couple of things that are different. And that's the focus of what I want to get to today, this y equals mx plus c. So in this case, it's y equals 2x. So the m is 2 minus 2, and the c is minus 2. So I wonder what if we typed in y equals 3x, what would that look like? Would it look the same as these, or would it look different? So have a think about that while I type it in. Y equals 3x. So obviously there's something different there. What if it was just y equals x? So y equals 3x sort of went up like this. Wonder what y equals x might look like. What do you think? I wonder if that's what you were expecting or it was something different. What makes those three lines all the same? I wonder if you could write another line that would be the same or similar to all those three. Perhaps it just might be y equals 2x. So this 2 in front of the x has something to do with the direction or the slope. We call that the slope or the gradient of the curve. This y equals 2x minus 2, y equals 2x plus 1, y equals 2x plus 3, y equals 2x. Basically what it's doing is every time we go across 1, we go up 2. We go across 1, we go up 2. Across 1, go up 2. I wonder what would happen if we change them all to 3x. Let's get rid of these and change them all to 3x. And I obviously didn't change 1. I left it as 2x. And we should be able to see which one that is. And hopefully you can see that these three are all the same. And this one's different. Why is it different? Because it's the y equals 2x one. We made that 3x. It would be the same again. So this y equals 3x. And these ones were a bit steeper. Why? Because it's a 3x. So every time we go across 1, we go up 3 now. We go across 1 here, we go up 3. There's that nice little triangle. Again, let's get rid of them and let's move it to just 1x. 1x minus 1, 1x plus 1, 1x plus 3, and just 1x. So 2x was across 1 up 2, 3x was across 1 up 3, 1x might be just across 1 up 1 perhaps. Perhaps that's what you think. Across 1 up 1, across 1 up 1, across 1 up 1. So this 1x means something there. And again, because they're all 1x, they're all parallel. They all have the same slope. They all have the same gradient. I wonder what happens if it's a minus. Wonder what would happen if instead of being plus y equals plus 1x, if we had minus 2x and minus 2x in all of these. Wonder what you think would happen. Well, let's have a look. Well, we can hardly see that one. Sort of going the other way now, isn't it? Minus x plus 1, minus 2x plus 3, and minus 2x. They're sort of going the other way. Remember, if it was just plus x, plus 2x, it was across 1 and up 2, across 1 up 2. Now it's like across 1 down 2, across 1 down 2, because the gradient or the slope is this minus 2. So that's the importance of this m in front of the x. We might leave it there and we'll use the other one.